Guys, I think we're good to go. All right, guys. Well, welcome to week 7, lesson 2. Thank you guys so much for being here today. Welcome back. So remember, if you haven't taken the exam yet, please go ahead and do so. 90% of those core assignments completed, and when you're done with the exam, that does not mean let me stop finishing any core assignments, discussion questions, or whatever the case may be. Please finish those up, okay? Let's go ahead and get started with today. A little bit of housekeeping. Tuesday, we covered class components and OOP. Today, we're going to talk about authentication and taking a look at the back end. So super exciting stuff today, okay? There are some links here. Here's the link to the movie app that we had played with last time. So you can actually go through the documentation and take a look at how we use JSON Web Tokens in the front end and the back end. If you're having trouble with that, that might be super beneficial. And then this other link, I believe, just opens up this guy. Or no, what does this open? Oh, no. This opens up the actual MERN authentication here. Kind of the entire process and where you can follow along, right? Super easy. So, taking a look at the schedule. Or is this the schedule? Nope, that is not the schedule. I'll have to close that. Let me pull up the schedule. All right. Schedule. All right, we are in week 7. As we all know, we have one more week. We're halfway done with week 7. Week 8 is coming up, which means that the last time to turn in the exams is coming up as well. So if you guys are at home and you haven't finished those exams yet, please make sure to complete those, okay? All right, give me 1 second and get down there to week 7. All right, so this is where we're at, off back end. These are some things that we need to read over. Probably one of the most important things is those environment variables. So you don't share your information with everybody around the world and they all just go into your app and just wreak havoc, right? So we don't want to do that. Tomorrow we'll take a look at some auth in the front end, and then we have that retake opportunity on Friday if you need to retake the exam. Do know that you don't have to wait till this day, okay? Some of us saw this and you're like, I can't ask before. Yes, you can, okay? This is just a little bit of information of when you could ask for the first retake if you haven't already done so. But that being said, use that weekend, finish up the exam, and then bada bing, bada boom, you have the last day to turn in the exam is this Tuesday, okay? This coming up Tuesday. So please, please, please have that done. And this is one thing I talked about it yesterday. I'm gonna discuss it again. Last chance to submit discussion questions and assignments. Close end of day, Wednesday. End of day, you need to have 14 out of 15 core assignments, okay? End of day, Wednesday, not Sunday, Wednesday, November 16th, okay? All right, that's probably the most important part from there. All right, let's keep moving forward. So those are some things that we need to understand. The next one is you win by an inch or a mile, right? And I like this one because sometimes you come up with some janky things to get your code to work, but it works. That's a win. That's a win for me, right? Inch or a mile, so remember that. All right, let's get started with our warm-up questions. Here's what I'm gonna do for today, guys. We have 3 guys in here. We're not gonna do warm-up questions, okay? We're gonna move forward past those warm-up questions so we can get to today's information, okay? All right, so authentication. Authentication, JSON Web Tokens, cookies, bcrypt. I'm gonna cover this first before we get to the rest of the stuff, okay? So JSON Web Tokens. If you haven't already played with this guy right here, this is an awesome, awesome, awesome thing. You can actually go ahead and take a look at your cookies right now, and you can decrypt what information is found in them. Now, isn't that a little scary? Think about it. A hacker could just pop this open and pull your cookie right now from a web page, and they can pull information from it. That is possible. I didn't tell this what the ID was. I didn't tell it what the first name was, and I didn't tell it what the issued at time was. I didn't. It was able to decrypt this guy right here into this, okay? So if we think that these cookies are that secure, that is incorrect. Okay, this JSON Web Token is not very secure in the means of what it's saving inside of it. So hopefully you don't save passwords in here for your user, okay? So just something to think about, okay? But what causes this to be a little bit more secure, right? It might be the question, because you just saw that I was able to decrypt this guy real quick and pull something out of it. So you might be like, oh crap, like how is this secure? Like, how am I going to make my website secure? Well, the beautiful thing about these is that even though you could essentially decrypt what's in here, The reason it's able to be decrypted is to check if the signature that you assigned is correct. So a JSON Web Token has a header, has the payload, and has a signature. Okay. Let's see. How unsafe is storing a user ID in there? That's a great question, right? After we just saw this, you're like, oh, user ID, maybe it's not a good idea, right? We're going to talk about how it is a little bit safer with that signature and why it's safer, right? So we have the algorithm token type as the header. Right now, none of them, but if you were to change this, you know, it would tell you a different algorithm, right? There's different algorithms out there. The payload is the data itself, right? The data that you are getting back from the server, and then the signature is hopefully something you're not getting back from the server. That's like, here's the signature I'm using, right? We'll talk about why this signature is so important, right? This is my awesome secret right now, but this is super important to not share this at all, okay? So the question was, well, how is storing a user ID in there unsafe? Well, you're going to notice that we will actually be verifying somebody to go into the web page by using the signature. Even though they have the ID, they still need to get a valid signature. So if they have the user ID and they send this with an invalid signature, it won't verify on the server side. So they still won't be able to log in, right? It's the same as if you have your own user ID on your computer right now. You've logged into some of these sites and you have that cookie still on your web page on your browser. And if your sibling or your parent or some hacker was to break into your house and try to log in using your computer, some of these web pages will not log in because the JSON Web Token has already expired, right? And when it expires, it's not gonna, the server's not gonna allow it to go through, right? The signature is gonna change. The whole thing is gonna change, right? You might still be able to decrypt the information inside of it, but you just won't be able to log in. Okay. So let's take a look at how that happens, right? So this is the JSON Web Token, probably the first part of this whole series, right? The most important part is this guy right here, okay? So as you see here, we have some data, we have an ID, we have a first name, we have an issued at time, okay? You can see down here, and it's a little bit big, maybe I can zoom out a little bit. You can see that the signature has been verified. Well, actually this has actually changed. If you change anything here, like it will recreate this JSON Web Token for you. That's a little scary, honestly. Because imagine you pulled somebody's JSON Web Token from their computer, right? Well, actually, if you pull it directly from the computer, you're going to have their signature. So just FYI. You can pull directly from somebody's computer and you will have access to it. But that's why we have something called HTTP only, which doesn't allow you to have access to this using JavaScript, right? But you could essentially go in and copy it and paste it, and depending on how the web page is created, you might be able to log into their account, right? This entire cookie depends on what they have set up on their site, okay? But that would be kind of difficult. You'd have to go, you have to copy and paste it, actually have access to the computer, take it, so on and so forth. And this would only last, a certain amount of time, right? So you'll notice though that you could essentially try to create a JSON Web Token. If you do know the person's ID and you know that the JSON Web Token saves a first name or something, you could try to, change these numbers and try to change the signature to get it to change the values in here to try to send it in and try to authenticate, right? But it's still going to, especially something non-sequential like an ID for Mongo. Yeah, it's a random bit of information, so it will take some time. Okay. Now do understand this, right? And this was brought up earlier. Every lock has a key. There will always be a way to go in. It doesn't have to be by, let me break in and get the JSON Web Token from the user, right? Let me do something else. There's so many ways to get this information. In fact, it doesn't even have to be getting a JSON Web Token. The person could just have access to where the servers are, and if they're able to go into the server, they don't need any of this. They have the database there, right? So there's different ways to be able to hack information. This is what we have so that the average Joe that's out there that has access to a computer doesn't just log into your account, right? And so this is what we have so far. This is one of the many things that we have. This one that we're covering today is a JSON Web Token, right? JSON Web Token is exactly what we just talked about. It has a header, payload, and a signature. This is going to be created on the server. It will be signed by the signature or the secret key, and it will send it back to you with the payload of information that you would like the application to receive. The application will receive it and do something with this information. Because it's sent over to the browser as a cookie, it will be saved in your cookies up here. So you'll have some cookies, right? 16 used right now. My goodness, these are all my cookies, right? Here, right? Crazy. You'll have access, right, to this cookie if you do HTTP. If you don't do the HTTP only, right? You could have access to it where you can use JavaScript to change it. Or you could not if it's HTTP only, right? Regardless of the matter, this is sent back to your computer, to your application, to your browser from the server. Okay, that's all we need to know for this so far. Okay. All right, so let's take a look at this. So if we go through this whole little section, right? Authentication, authorization. Cool. So we know that authentication, we need to be authenticated, and am I authorized to see the information? I might be authenticated where I'm like, we know who you are, but are you authorized to see the information, right? That is pretty easy to understand. The next bit it says, look, we have a user model in bcrypt. So the next piece of the puzzle is like, hey, we have this model that you've played with before. You had a first name, you had a last name, you had an email, you had a password. But hey, have you thought of bcrypt? You might say, well, what the heck is bcrypt, right? Hopefully we all know what bcrypt is. Give me some ones and zeros in the chat if you know what bcrypt is. I want to know. If we all know, that'll be much easier. Nice. Okay, cool. I missed a question. Sorry about that, Paul. But so long as the secret key is saved as a .env variable, you still shouldn't be authenticated server. So it will be authenticated server side, but it will be available in the environment variables. So you'll be able to use the environment variable to authenticate it without the environment variable being out there. Essentially on the server, it will be on the server. The environment variables are so that when you upload it to like GitHub or different places and you have the code in there, it doesn't upload all your secrets, all your API keys and all this.
So I meant like more if someone on the client side did access the signature, like even if they had the signature, they shouldn't be able to be authenticated with that because we have protections on the server side, right?
Oh no, if they have the signature, they're going to create their own cookie that's going to be able to log into your computer, to your server.
Even if that secret key is stored as a variable?
Yeah, so even if it's stored as a variable, if they get it, like you give it to them and they go and they just make a new cookie.
Yeah, that makes sense.
Yeah, because because then they will sign it. They will sign their own cookie with the signature that is supposed to be saved on the server. Yeah. So yeah, they'll be able to use it. So essentially this is the lock. And the only key is found on the server. If you make a copy of that key, give it to somebody else, they're going to be able to open that lock. Yeah. Good question. Very good question. All right. So the next bit of it is the bcrypt. Why is bcrypt so important? Well, I want you to imagine that we did give the key to somebody that was working in the same company with us, right? And we're like, hey, here is the environment variable, right? This is the information that you need, right? And they have it. If you left the company, they hate you, right? They want to break down the company. They can leak this information out, right? Somebody now has access to your databases, right? So now the person that is on your database might see something like this, right? Thanks to bcrypt, because this password has been hashed, okay? If bcrypt was not in place, and actually a few years ago, not too long ago, a lot of websites were saving the password as plain text. Okay, so you can still see some articles about how Facebook, had a bunch of their passwords saved as plain text and all kinds of different things. It was a little while back. It's not recent, right? But it was happening. And there's still today a lot of people that when they first start creating web pages, and they're creating these applications, you always have somebody that creates this application for a company that their brother owns, and this company is a large company. They start using the application that the brother created, didn't know anything about security, and now you have a huge security breach because somebody knows that the database has a bunch of plain text passwords. So then they access the database and then they get all of these passwords that are just plain text, right? It can happen. It still happens. You'll hear about it. But it's not as often as it used to be, just as SQL injection is not as often as it used to be. Can it still be found? Absolutely. Just like people that forget to put environment variables and they submit all of their code to GitHub and all these scrapers, because there's web scrapers, right? If we know what a web scraper is, it scrapes the internet for information. There's web scrapers that people have created to scrape GitHub. And whenever there is a key that is added, it lets them know and it makes a copy of it, right? And so that can still happen, just like any of these flaws that we're talking about, right? But what does this do? Well, it allows us to create something like this. So even though I created a very weak password, at least when the person opens up the database, it's going to take a little bit to guess, right? It'll take a little bit to guess this, right? And so our hope is that even though my password was 1234567 and honestly, that would probably be hacked super quick, right? But even though it was something simple, it doesn't look like it was that simple, right? And so let's say an average Joe, found my account. They might have a hard time with this. But do know this. Hackers are going to continue trying to hack your account. So if you have a weak password, it does not matter what the hash is. There is lists of thousands of commonly used passwords that they're going to run against your account to see if they can get in. And if you have a weak password, it doesn't matter how many times it was hashed, they're still going to get into your account. This is why weak passwords are a no-go. You need to have a strong password so that they can't take a guess using these large amounts of lists that are available anywhere on the line, right? Massive, massive lists of passwords that have been guessed, right? And people still use them. Okay, don't use them. Use a very complex password of digits and numbers, right? And then when it's hashed, it'll be even more difficult for them to find it, right? And so what this means is that it's going to be hashed out in a way that if the person's trying to break this hash and has a very big list of passwords, it's going to take a very long time for them to break into your account. The old, let me type the email and have this Python program that is just putting an email and a password and just keeps clicking log in until we break in, right? Or just is sending these requests to the API directly, right? They can do all kinds of different things to try to access your account. The hope is that even if they have your email, they don't have your password, and hopefully you have a strong password. Okay. Yeah, exactly. We're making it difficult and not worth their time. That's exactly what we're trying to do, right? We're hoping that they just they would rather move on to the next victim, right? So that's what we hope. Okay. All right. So we use bcrypt. Now, bcrypt is going to allow us to hash the password. That password, I'm going to give it to you, was 1234567 right? It doesn't look like 1234567 right? So even though I had a weak password, it would do this for me, right? We're also adding some salt rounds, and so you'll hear salt being mentioned here and there, and you'll be like, well, what the heck is salt, right? Pepper? Is pepper necessary? What's up? No, salt is just bcrypt adding these extra lines of code at the end to make it even more difficult for somebody to break this password, okay? In this case, I think the strongest, is 10. I think that's like the max that you can set it at. That's essentially what we're doing. Okay, nothing too crazy. We're hashing a password. We're making it impossible to, not impossible, nothing's impossible, but we're making it super, super, super difficult for them to break it. Okay, that's what we're doing there. Okay, that's another security measure that we're taking. So not only do we have the JSON Web Token signed, if they have access to the database, hopefully they don't. If they do, they'll have access to the email and hopefully just the password that is, this hash password. And so they won't be able to get much from that. Okay. All right, cool. So there's that. So let's go back to their account. It just says, hey, let's use bcrypt. And it tells you how to do it. It says, okay, we're going to be taking an email. And honestly, this one is a little outdated. Thanks to Miss Gray, we found out that you don't even have to use this validate function, right? I don't know if you could be called a function or a method. I'm not entirely sure how it's referred to in the documentation of Mongoose, but whatever this method or function or whatever it is has a validator, and it validates using regex if the value that was inputted is a match. In this case, this is the regex for an email. Okay. then you give a message of please enter a valid email. If you look at the Mongoose documentation, there is a Mongoose match. I don't know if it's this one, maybe it's here. All right, so there's that. They're not using it, I think, the way we did. I wonder if it's under validations. Mongoose match validator. I think that one's a better one. And please be here. Let's see. Yeah, we have match here. All right, cool. So where is match? I guess we have to click on it, take us to a different place. Match. Okay, here it goes. Match, regular expression, creates a validator that checks if the value matches the given expression. And the same way we've used the min, the maxes, and all of them, we can do the same thing here. We just do match, colon, and then an array, and then the array, the first piece of the array is the regex, and the next one is going to be the message. Right, so nothing too crazy. The match one's actually pretty easy to use, just like you've been using the other ones. So it tells you how to use it up there. I don't know if they have it down here being used. I can't find it when I look up match. It just pulls up this one. But that's all it is, right? Let's see. Yeah, it doesn't pull it up, but that's all it is, honestly. It's as easy to use as the min, the max, all of them. It's just an array with the first argument of the array being the regex and the next one being the message you want to return. It's that easy. So you don't have to use this validator. Okay? And we'll look at it here in a second. If we don't fully understand it, we can code it out. Okay? That's all it is. It's just validating to make sure it's a valid email. The next one is a confirm password. This one is pretty interesting, right? Why do we have to use this user schema.virtual, right? Well, we don't want to save the confirm password. The confirm password would be taking a useless space inside of our database. We don't need to save that information, right? We don't want to go here to the information and see name, email, password, confirm password. Like, it doesn't make sense, right? We don't need the confirm password saved. So what do? We create this virtual field. So in order to create this virtual field, you can just copy and paste this. But what this is doing is saying, hey, user schema, check this out. I have a virtual field. I'm calling it confirm password, okay? I want to set a getter and a setter. This is what's going to get the confirm password, and this is what's going to set the confirm password. That's all it is. Nothing too crazy. So once again, user schema, I need a virtual field created called confirm password. Here's my getter and my setter. My getter is going to get it. It's going to get the confirm password by using this, right? This dot underscore confirm password. And the setter is going to set it to this dot underscore confirm password. This underscore needs to be available here because that's how it saves it. And this one does not have to have an underscore. This is just, a key, confirm password. Okay. The next is the pre-validate. Before validate. Before it validates, I need you to do this. Okay. It's going to check if the password is equal to the confirmed password. And if it is, if it's not, it's going to invalidate. But if it is, it's going to say, okay, go ahead and go next, which means the next piece of the puzzle, right? It's going to validate, do whatever it needs to do. Okay. That's it, right? This is pretty simple. And once again, this was the user schema pre-validate. Before we validate, I would like to run this function. This function will take a callback function called next, which will allow me to run the next piece that I need, the validate, right? If this password is not equal to this confirmed password, whatever I'm checking right now, right? Then what I'm going to do is I'm going to invalidate, which means I'm going to throw an error, and it's going to say this. Confirm password, passwords must match a confirmed password, right? And then go next. I do want you guys to, this is very powerful. I would honestly use this right here, but I do want you guys to also know that, or note that you could have done this in the controller. You could have said, hey, let's go ahead and double check that the information coming in from the user, this dot password is equal to the confirmed password. You could have validated in the front end as well as the back end, right? You could have done all these different validations, but they could happen back here. They can happen in the front end. They can happen in the controller before it even gets to this model here, right? And thus not needing this. But I think it's better to understand how to use Mongoose so that you can take advantage of some of these really cool, nifty things that they have. Okay. Model kind of makes sense. Yeah, the model has some really cool, interesting things. There's also other items, like for instance, you'll notice that the unique one, if you look at Mongoose Unique, it's like, hey, it might work and it might not work. And the documentation literally says that, right? It says, if something happens, this is not a validator, right? And so there's different things out there, different libraries. You can find some, you can use them on your app. So that to make sure that it's unique, you could also just create your own little unique check inside of the controller where it's like user.find, if name is equal to this name or whatever the case may be, if you're looking for an email. And then if a user is found, you can return a response with user already taken, right? And they wouldn't be able to finish the process, meaning they would get the validation error message back and say, hey, you can't do that. Go ahead and try a different name, right? So you could do that in the front end, not in the front end, sorry, in the controller before it goes to the model, okay? Now it talks about bcrypt. It tells you how to install bcrypt. Nothing too crazy here, okay? But real quick, I want to ask, because I'm going through this like, yeah, this isn't too difficult, but that doesn't mean that it isn't difficult. So is there questions right now up to this part that we need to go back to and cover, right? If there is, please let me know. That there's no harm in it. I'm just, I'm wanting you guys to feel comfortable and put some positiveness, if that's a word, right, out there, that this isn't too terribly difficult, right? If you just follow along. But that doesn't mean that it can't be terribly difficult. Then we need something cleared up. So please let me know if you do, okay? The next thing is bcrypt, how to install bcrypt, then how to import bcrypt, and then how to use it inside of your model, okay? What does this mean? Well, let's take a look at what we did. You see the user schema, name, email, password. We don't see a confirm password. Why not? Because we're using a virtual field, okay? Name, email, password, a virtual field. User schema, dot virtual. I'm adding a virtual field here called confirm password. Here's my getter and my setter. This is what's going to get this confirm password, and this is what's going to set this confirm password, right? When it creates it, it adds an underscore to it. So we have to understand that. So this is how it's going to save it. And I believe this is for like virtual fields, but you'll also notice the ID has one. I couldn't tell you why they both have the same underscore, but do know that it's there, okay? Next is going to be that user schema.prevalidate. So I have this, I've done this. Before I validate, I need to check something. I'm going to check if this password is not equal to the confirmed password. I'm going to do this, then next. Okay. And then it goes to or this one also ran as well. This is the pre-save. Before I save it, we've checked everything. We've checked the confirmed password and the regular password. We're good to go. Now is the dangerous part, right? We need to save the information. But before we save it, we have the plain text password right there on the server. But we don't want the plain text password inside of our database. That's why we run the user schema.pre. Before I save, I would like to hash this password using 10 rounds of salt, the highest amount that we can, right? Want to make this as difficult as possible for a hacker, okay? Then I'm going to take that hash and I'm going to say this password, this password, because this password is referring to the password in this schema at this moment in time, right? In this model, right? Is now the hashed password. Then I'm going to say next, calling that callback function of save, saving it. We're good to go. It's been saved, right? More sodium, yeah, for sure. Completely inedible, yeah, for sure, exactly. I like that. So yeah, so that's exactly what's going on here. Nothing too crazy, okay? All right, so let me go ahead and go to the next one. So now it says, okay, look, we're going to do some registration, and it's going to talk about some information about registration. I just want you to know we're going to skip through this because you're going to see this at the end, okay? You don't need to read that, okay? This you do need to read, okay? This is like, look, buddy, you're getting into some dangerous territory now where you might want to save an environment variable, okay? Because you're going to be using a secret key, right? And say, okay, look, what do I mean? by that secret key. Well, later when you're doing this JSON Web Token stuff, you're going to need to use this secret key. And look at mine, you can see it right now. You could hack my application if you wanted to, right? If I uploaded this to GitHub, the hacker would be like, hey, look, somebody just uploaded a secret and it's called my secret. Oh, I guess this is the secret to their application. Let's keep an eye out. And if they post any application anywhere that looks similar to this, we'll go hack it, right? And that's not what we want. So we can use these environment variables, right? It tells you how to do it. I actually haven't done it yet on this one because, you know, it shows you the password, but it's not too difficult. So we'll open this up. And where is this? We're going to go ahead and kill this terminal. All right, so we're going to do exactly what it says. It says, cool, you need to do something. A secret key is equal to some secret key. Cool, you could do it over the terminal, but we're not going to do that. It says npm install.env. Okay, let's do that. Okay, kind of small. I need to make sure that I'm typing correctly, right? All right, npm install.env. All right, so we're installing it. All right, let's make sure that it's installed. Package.json. And we see it right there. Cool. The next thing that I want to do inside of my server, according to what this says, well, it says two things actually, but this one's actually very important. It says, with the .env installed, you can create a hidden .env file in the same folder as your server.js file. Important, do not commit this if your project is a repository. You can avoid committing it by adding the string .env to a gitignore file. Okay, that is super important. Okay, so let's go ahead and do that. We're in the server. We're going to go ahead and create a .env file. You'll get this little like clock cog, right? Let's make sure it's in the, yeah, we're good, right? Yeah. Okay. The next thing that I'm going to do is we're going to create it. We'll just create it in here. That's fine. That's fine. Click on the server, .gitignore. Okay. .env. We don't want that there. .ds_store, I think it is. This is an annoying little thing that comes up for Mac users, so you might not want to send that one either. Also, another annoying thing when you're uploading things, node modules. Right. And sometimes this doesn't work for me, so I put this just to make sure I get the right one. Okay. Yeah. So now I just want to make sure that this is not sent up to, when I initialize Git in here and I push it up, I don't want this being sent out, right? Because you're going to have two files or two folders in here, do know that this gitignore might just actually exist outside of both of these folders, right? Because you're going to have a client and a server, and just add it there, okay? But here we don't have that, so I'm adding it in here, okay? The gitignore. The .env exists in the server because that's where I'm using it. But this, right? All right, cool. The next thing it says, look, we don't want people seeing our secret project values. If you see the code in the wild, here's the format of an .env. First secret key, right? Second secret key, it's all capitalized. We'll take that one and we'll add it to our .env. First secret key, and as you know, I had already told you guys, I've been using it, I've been using my key out and about where everybody can see it, and that's dangerous, right? And I don't want people to hack me. And so what I'm going to do to make sure I'm safe is I'm going to find where I'm using these secrets, such as, I know I'm using it, not in here, I'm using it in here, my awesome secret. I'm going to go ahead and copy that. And we're going to change it. My awesome secret sauce. Just because, you know, a lot of people saw it and I wanted to change it. And hopefully this is not your secret, guys. Hopefully your secret's more like right? Some crazy thing, right? So when you're creating this signature that that you have, hopefully it's something like this that nobody's gonna take a guess, okay? And you've probably covered in Python that you probably heard that you could just hit the keyboard and get something like this, yeah, for sure. Or you can use a password generator that generates some random, right? Yeah, keyboard face roll. Yeah, I like that. Yeah, for sure. So you can do something like that, right? But let's go ahead and let's undo this. Okay, but this is what I'm going to use here. Okay, so in order to use this, I can then go back and paste it. But it's not going to work like this unless you do something, right? You have to do something first here, though. In the server, you need to add this. So you're going to copy it, go back, add this to the server. They literally say as soon as possible. I could probably do it on top of that, but as long as it's on the top, I don't think it really matters. Oh, it's okay. I'll just add it there. That's cool. All right. Now here it says, okay, you can say now that the secret is process.env.firstSecretKey. All right. Sometimes you'll actually see it like this. Process.env. Let's see where we're at. Sometimes you're going to see it like this. Process.env. Right. But I think hopefully you guys can kind of see how we can take that out of process.env. Any takers? Anybody know how we can just use first secret key? Nice. We could deconstruct it. Okay, let me see if I can take it. First secret key. First secret key. Now I can add that anywhere I had that secret. So where is that other? I think it was up here. There it goes. Okay. It's there. And then I think I also use it in here. Yeah, right here. Secret is equal to. And this one I just had secret, so I could say process.env. Sometimes the process.env is not fully saved. So one way to test it out would be to make sure that there's a place where a console log is going to run. And you can console log process.env, whatever you just saved, to make sure that it is actually available and it is showing and there is no problems. Right here we say const, something's happening here apparently. It says, apparently I did something wrong there. Let's go double check to see what happened there. It's not there. I have too many things open. Let me close some of these guys. And this one's not necessary. Const process.env. I think that's it. Let's see. See if it works now. Unexpected. Oh, okay. Ah, silly me. Why did I put it in there? Sorry about that. I put it in here. Yeah, that's what happened. All right, let's give it a second. Do its thing. Oh no, something else. Let's see. What's this? JSON Web Token. Cannot find module. JSON Web Token. Config jwt.config. Config jwt is equal to required JSON Web Token. I thought I added it. It should have been added. Let's double check. Oh no, it wasn't added. I know it was added because I used it earlier. Yeah, that's interesting. Okay, we'll just do this. Let it do its thing. And then I believe believe I just did it in the controller as well. So let's just double check controller. Yeah. Yeah, we're good. All right, everything's working well. I don't see the secret message anywhere else. And honestly, I'm very lax about it right now because I'm not going to upload this and it's not for real. But I wouldn't be as lax. I would probably like go through everything and make sure that that's not saved anywhere, right? So my secret, right? Just make sure and check everything. Okay. All right, cool. So now I have access to those environment variables and it's supposed to do everything for me there without having to show everybody, you know, what these things are. You'll have them saved in something like this, okay? Nothing too super crazy. Awesome. So that is the environment variable part, right? Pretty easy, not too crazy. Is there any questions about that? Because I guarantee you there probably is a question, right? Zeros and ones in the chats. How are we feeling about that? Was that pretty easy to understand? Not too bad. Not too crazy. All right. Nice, nice. Sounds like 0.0002. One just practice. Okay, cool. Cool. All right, nice. All right, so we've done that. Now we get to JSON Web Tokens. We've already talked about them. It's funny because I did have it installed because I needed it to use it earlier. So somehow I uninstalled it. I don't know what happened. But you need to install the JSON Web Token. This is what creates the JSON Web Token, okay? It's a third-party package, okay? This right here is the payload that you're creating. This is what I kind of changed, and I added first name because I want my payload to include a first name in there, what I sent over to the database, right? You can do that as well. And then, yeah. So that part is honestly just plug and play. You follow exactly what's on the dashboard there and it'll work just fine. Okay. There's some other things that you do have to change and it walks you through them. It says, look, when you're using cookies in Express, you need to make sure to get a cookie parser, okay, to read through the cookies. This is a package, npm cookie parser, okay. You can then say app.use cookie parser so I can use it. And then you need to make sure when you're using cores, you set credentials to true. What does this mean, credentials to true? That means, hey, I'm receiving and sending cookies, okay? I'm sending some type of authentication something, right? Credentials true. Please make sure, this is a big one because we will forget. And when we forget, you will keep sending it and sending it and sending it and it will not work. It's also the same thing in the front end, okay? All right. Then you see here, it says, look, then you can send a response cookie, name it some name, and then you can send some data, and then you can say HTTP only true so that they don't have access through the JavaScript on the web browser, right? So it's a little bit of information. The most important part of this is just this right here. The rest of it, I wouldn't really read through. I mean, if you would like to read through it and get a little bit deeper understanding, definitely do so. But if you're trying to get this implemented right now, don't worry too much about this. Just do this part right here. You'll get this implemented and good to go, okay? That way you can play with it and then understand how it works, read through it while you're playing with it, read through the documentation. The next thing we run into is this async await. You can change it from using .then, right, to async await. This is our, where is it? Async await, our .then .catch hell, right? You can do .then .catch, and you can run into some errors when you start saying things like this, like super crazy. .then, second function, .then .catch, right? We're using .then .catch in this case, just because you guys are a little bit more familiar with this, right? But honestly, this asynchronous way is so nice. You could just set a function to be asynchronous, and you can put this in a try catch block. Your catch is going to catch any error that comes through. And inside of your try is where you would say, hey, this constant, for instance, when we create a user on user.create, we could say const user is equal to user.create request.body. And if it creates the user, it will save the user here under this const, right? And if it doesn't create it, it'll run to my catch because there's been an error, right? So it is a nice way of doing it. HTTP is not better than HTTPS, but we do have to set it. That's the parameter that we have to send in. Those are the options that we have to send. So it doesn't read through the browser. So the browser doesn't have access to the cookie. Like you'll be able to see it, but it won't be able to use JavaScript in the browser to access it, according to the browser's rules. Right? Good question. Then we get to the login, logout. Okay. This is the kind of the last part. Okay, look, now let's set up the login and the logout. We've set the rest of it up. Let's set up the login and logout. Okay. Let's take a look at how this would work. If I'm moving through it too quickly, pause, say, hey, Robert, let's take a look at this again. I don't understand this. Ask questions, okay? All right. Am I moving too quick? Am I okay with starting this section before we cover anything from the last one? Zeros and ones in the chat. Let me know. Okay, cool. All right, awesome. Okay, so our login, you're going to see it change to asynchronous. Well, the one I created, I did not use asynchronous so that you guys can see how it would look using just .then.catch. But in this case, they're saying, look, I want you to set it as asynchronous so that we can just say, look, const user is going to be await. Await is used because we have async. Await waits for this promise to fulfill or reject before doing something here. Okay. User.find1, and it's going to look for one with an email of whatever email you specified in the request.body. Okay. If the user is null, meaning that the user was not found, that there was no user found, then you could just return a response. This says send status. It is not send status. It's response.status 400. So I'm not sure why they put send status, but it's response.status 400.json because you're sending some JSON back. Okay. Next, you want to double check their password because they're logging in. They're not being registered. Correct password is equal to another promise by bcrypt, await bcrypt.compare. So it's going to compare the request body password and the user password. Here's the first bit of confusion. You're like, wait a minute, bcrypt hashes things. How is it going to compare a print password, a print not hashed password to a hashed one? Well, bcrypt has a way to compare them running an algorithm to see if they are the same. Okay? So this will return true if they are the same. It cannot decrypt the hash, but what it can do is figure it out under the hood somehow, okay? And it could say, look, these passwords will match, right? And if they match, then they will go ahead and allow you to move on to the second part. If the password does not match, it will return that response that you need. But if it's good to go, we can then move on to the most important part of this whole process, which is to create that JSON web token, right? Yeah, it does kind of imply that hashing is not random, right? This is a valid point. But even though it's technically not random, right, or might be pseudo-random, the importance of it is that it still makes hackers try to implement something to figure out these passwords that are hashed, right? And it'll take a long time. And I want you to notice how easy it is to use this. I guarantee you hackers right now have something that's using bcrypt that says, look, compare, like if they have access to the hash password from the database, compare this enormous list of passwords to the hashed password I have. And if it finds one, it will say, hey, this is the password. This is why we should not have simple passwords. Okay. This might cause some fear and be like, what if they have my hash password? Well, they're going to have your hash password if they broke into a database. That's the only way that they're going to get your hash password. Okay. So it still means that they had to hack their way into a database. And that still means that maybe that the password still has to be the same, right? So there's still a lot of ifs, right? And even if they have it, they still have to run all of these different tests to try to figure out what your password is. Yeah, right. They deserve it at some point, hopefully after 60 years, right? So for sure. But yeah, so after all this is good and well, right? And they say, okay, good. We found the user. Great. They have the correct password. Let's go ahead and give them a little slip of information. And I could say, look, take this slip, and if you ever want to request something from me, you can give this slip back to me. I will read it, make sure that you are you. It's like an ID, right? And you'll have access to this information. That's what it does, right? So then the server takes this piece of paper and signs it with their signature, right? And says, okay, I would like to send you back an ID. This will be your identification number, and I'm going to put your first name on here. Here's this piece of paper. You can use it however you'd like, but when you come over here and you ask for and you request something, I need that piece of paper. I need to check it every single time. If you don't have that, I'm not going to give you the information. Sorry, right? It's the bouncer, right? So that's exactly what's happening. So here in this user token, we say const user token. I'm going to create a constant called user token, and I'm going to assign it to JSON web token.sign. What this does, it creates that JSON web token. And inside of that JSON web token, it is going to add whatever payload you want it to add. In this case, it's just an ID. Okay? I changed it to also send a first name. It sends the ID and any other parameters that you would like to send over, or any other key values that you would like to send over, right? It signs them. So it looks like it's been, encrypted. So it's not readable data unless they take the cookie and they put it into a program like this and they read the data. So it is possible to get the data. The only impossibility, though, unless you gave them this, unless they guessed it too, right, is that you signed it with a very particular key. Even though they have your ID and your first name, if they don't have the secret key that you signed it with, your server is never going to authenticate it. Because when they get this information back, as you're going to see here in the, well, this is the login, I guess, but you'll see later after the login, the server is going to see if the request coming in now for any other resource has that particular cookie. That cookie. I'm going to draw a cookie because I don't want to type cookie. Cookie, right? Oh, did somebody say they're taking off? Oh, you're taking off? Oh, okay. See, buddy. Cookie, right? They test it, and if it's good to go, they allow you to access these resources. This is the most important part, is this user token. Now, this user token is sent in through a cookie. So the cookie that is saved inside of that cookie is your JSON web token. That has been signed by the server. And anytime you request information to the server, they're going to check to make sure that cookie has been signed. And if it has been signed by the server with this key that they have down here, right, then they'll give you access to whatever you need. Okay, that's how that works. Notice there's some other things that have been added here, such as HTTP only true, because we don't want the browser to have access to these cookies. Now, this is not terribly secure data, so if you wanted to make it easier on yourself and have your application read directly from the cookie and be able to access it, you just don't have to put HTTP only true. But do know that this also opens you up to an attack where somebody can say, hey, let me use some JavaScript to have access to this cookie, and then I'm going to take this information with me so I can do something with it. Okay. All right, cool. So let's move on to the next part. We have how to update the register method. It gives you it walks you through exactly how to do it and how to log out to clear your cookies, right? It then talks about the authorization and middleware. And this is, I think, the cream of the crop, honestly. This right here is creating something, a middleware, to authenticate the person before they have access to these specific routes. So before they can access all the information on this specific route, they have to get authenticated. Okay? This authentication is going to happen upon the user requesting information. And when they request information using Axios, they need to make, if you're using Axios, you need to make sure to put with credentials true inside of the Axios call. If you don't, they cannot use your cookies. You also, on the server, have to say with credentials in your cores so that you can use the cookies and be able to read through them. So they're going to be both in your code. They're going to be on both sides. Remember that, okay? Then you can use JSON Web Token, JWT, to verify the cookies coming in that you've saved under the key of user token with the secret that you saved on your environment variables. And if it's good to go, you can go to the next little section. If it is not good to go, then your status is going to be a 401, meaning that they are not allowed, right? Verified false is the JSON information being sent, okay? They give you this information here. They tell you how to use it, right? How to use it as that middleware. But it kind of ends there, right? Kind of leaves you on a cliff, right? This is, I think, a copy. Oh yeah, this is a copy of one. Well, I'm here to show you that there's a little bit more that you can do here. Let's take a look at that. I think that's what everybody kind of wants to see. Where is this JWT? I have it somewhere. Let me find it. Here it is. In my JSON Web Token, in this application, this one was a movie app, I have also added a is logged in. It has an authenticate, and it also has a is logged in. Okay. The authenticate is doing something more as well. Not only is it going next, meaning yeah, you can see the next route. I am using the request object that usually gets request.body, request.params.id, and whatever else is in that object. I am adding my own custom key called token. I can add whatever I want to this request. So the request coming in already has some key value pairs in there. We've already done request.body. We know what that has. Request.params.id. We know what that has. But we haven't used our own custom key in there. So here I'm saying request, add this custom key, and the value is going to be the payload that I receive here. This means that the payload that was sent over to the front end that is saved in my cookie, once it's verified, once they request information, once we verify it, that payload is there. So I can then read the payload and I can save that in my request as token. You could change this to banana if you wanted to. It would still work. Okay, but I'm not going to do that. I'm going to save it as token. Okay. Well, why is this so important? Well, we'll talk about that here in a second. Tomorrow we're going to talk about this one. This was a really cool one too. Is logged in. If the user is logged in, right? Or let's check if the user is logged in, sorry. We're going to take some information from the front end. We're going to take their cookies. And if they are logged in and everything is valid, then I'm going to send back an object. And this object is going to be the user. And I'm going to send back the ID. And I'm going to send back the first name. Okay. This will be very beneficial if your application has been sitting there for a while, or maybe you refreshed and you don't have the object anymore. It's deleted from state. And you want this object back in the front end. Right, and this object might have information that you need in the front end, such as the first name or the ID to be able to use it in different sections. The is logged in does that. It verifies that they are logged in before they send over the object of the ID and the first name. This is how you would access the ID and first name without using JavaScript to try to access the cookies directly on the browser. We're using this because we set HTTP only, meaning that we could only request and send information through HTTP, and we can't get it directly through the browser. Okay. Yeah, good. I'm glad, Paul. That right there is how you can get this token. And let me show you one last thing, how we're going to use it. We're going to use it tomorrow, but here's how it works in the backend. if I wanted to create a movie and link it to a user, I can now link it by sending a special key. I can call it owner, and I can send it the request.token.id, because the token, remember, had the ID and it had the name. If I wanted to, I could also add another one that says owner name is request.token.firstname. And that is pretty much everything. Any questions?
So we are creating a user object and giving it that variable token,
Well,
basically.
what
When
we're
when we
doing is
hit
we're,
is logged
go
in,
ahead.
when we hit the is logged in middleware.
Let's see.
That
When
is
we
so
hit the is, yeah, tell me what you mean. Tell me what you mean.
okay. So when we hit is logged in middleware, we verify to make sure the cookie is good, and then we do a find one and give it a like we create an object with the user data from the database, right?
This is a good question. So you said middleware. I'm actually not using this as a middleware. The is logged in is not a middleware. The other one is a middleware.
Okay.
This one is a path. If you go
Oh,
if you use a use effect in your application, the minute that the application loads, you can use a use effect to go to API version 1 is logged in, and if they are logged in, they'll get back some information. If they're not, that's just going to be empty, thus telling your front end, hey, this user's not logged in, redirect them to the login page.
okay. Do you have to use post methods to send cookies?
I don't believe you have to, but I send post methods because post methods for me are things such as being logged in,
Okay.
right? Log out is under get, but you'll notice that my register and my login are all under post.
Well, it's probably more secure anyway, huh?
Correct, because if you do an app dot, you can literally do an app get by putting it in the URL and clicking
Right.
enter.
Right. Okay. Cool. Very cool.
Mm-hmm. Yeah. So this was beneficial.
Play with that tonight, and I think with this, like I was just approaching it completely wrong. I was trying to do like all the logic um, in app.js, like
Mm-hmm.
doing for basically for every route, I was trying to do a use effect Axios call and take the cookies, decode the cookies, and it was messy. This is clean.
Mm-hmm. Yeah, because now you have an object on your side. It's saved on your, on the application, and you have access to it. And then you don't even need to verify anything in the front end because the back end is doing the verifying. So when you're trying to access information, that's when you could then, for instance, let's go to the routes.
So that'll be like
That's
the
when
res.user basically, huh?
that would be the middleware. That would be, hey, if the front end application is trying to get to this location, I want you to authenticate them first.
Right.
And there on your application, all you have to do, it's a quick, do I get a response? And my authenticate's going to send a response of, not allowed. And you can just do a quick, if not allowed, go back to, redirect them. So you don't have to check any cookies or anything because the cookies are already being sent back to you in the beginning, or upon being logged in. And you can save that to global state. What I mean by that is somewhere where all components have access to it, such as using context API, right? You can save it globally so that then anywhere in the application you have access to the ID and to the the first name.
Yeah, I think that's what I need to do. That'll be more tomorrow stuff, huh?
Yes.
Okay, cool.
Mm-hmm. Yes, sir. Well, if that's it, then I hope everybody has a great night. Everybody online, thank you guys so much for joining. Everybody have a wonderful night, and we'll see you mañana.